Okay, let's answer problem number 3.3. We have the limit of the square root of x minus 3 all over x minus 9 as x approaches to 9. So if we evaluate this directly and x is equal to 9, that will give us an undefined answer, because for this function the domain cannot be equal to 9. But let us evaluate if there exists a number where this function approaches to as x approaches to 9. So ang denominator, we could rewrite this as the product of ito. So let's just copy the numerator, and the denominator could be written actually as x is just the square root of x squared, right? So we could rewrite this as square root of x squared minus 9 is just the square of 3. So what we have in the denominator is a special product, diba? So this is now in the form a squared minus b squared, wherein a is square root of x and b is 3. And we know that the factor of a squared minus b squared is the product a minus b times a plus b. Okay. So as x approaches to 9, so this becomes the limit of square root of x minus 3 over square root of x minus 3 times square root of x plus 3 as x approaches to 9. So we could cancel this out. Isang grupo to. We could cancel this out, So what remains is the limit of 1 over square root of x, wrong spelling, square root of x plus 3 as x approaches to 9. So that will give us 1 over, so evaluate na natin, 1 over square root of 9 plus 3, that's 1 over 3 plus 3. So the answer is 1/6. Very easy. Now let's try problem 3.4. We have the limit of x squared minus 1 over the square root of x plus 3 minus 2 as x approaches to 1. So how do we solve this? Okay, so if you recall our lesson in rationalizing the denominator, we could manipulate this in order to change or to rationalize the denominator. Why do we need to rationalize the denominator? It's because if we directly substitute 1 to x here, so that becomes square root of 3 plus 1, which is 4, and square root of 4 is 2. So 2 minus 2 is 0. So magiging indeterminate na naman siya. I mean undefined. Okay? So what we will do first is to rationalize the denominator so that we could arrive at a different form of the same function. Okay? So let me do that. So that's the limit as x approaches to 1 of x squared minus 1 divided by square root of x plus 3 minus 2. Then multiply it by the denominator. So x plus 3, no, the conjugate of the denominator. That is how we rationalize, diba? So multiplied by its conjugate. So that's square root of x plus 3 plus 2. Okay, so this will give us the limit as x approaches to 1. So in numerator, i-multiply muna natin x squared minus 1 times square root of x plus 3 plus 2. And the denominator becomes, ito, special product na siya. This is a minus b times a plus b. And the result is a squared minus b squared. Diba? Special product. So that means ito siya, if our a is square root of x plus 3, so a squared is x plus 3 minus our b is 2, so b squared is 4, so minus 4. Then continue evaluating. So that's the limit as x approaches to 1 of ito, let me copy this again, minus 1 square root of x plus 3 plus 2 then divide it by this will become x plus 3 minus 4, which is x minus 1. Okay, so this time di pa din tayo makapag-continue because if we substitute 1 to x, 0 pa rin siya. Pero if you notice, the numerator is x squared minus 1, which could be factored out to x plus 1 and x minus 1. So pwede nang makancel to. Okay, so let's do that. So this becomes a limit as x approaches to 1 of x plus 1 times x minus 1 times square root of x plus 3 plus 2 all over x minus 1. So we could now cancel this out. This one. Cancel that out. So ito na lang yung function natin in which wala na siyang 0 na denominator. So mag-substitute na tayo for the limit. So that would become 1 plus 1, namali. So 1 plus 1 multiplied by the square root of 1 plus 3 plus 2. So that would be 2 times square root of 4 is 2 plus 2. The answer is 4 times 2, so 8. So our answer is 8. Okay? So pwede din natin i-check sa calculator. So if we use a calculator, let me open the calculator. So kung i-check natin using a calculator, ganito yung gagawin natin. So we have, let's just write the function. We have x squared minus 1 divided by square root of x. So as x approaches 1, kung mag-substitute tayo agad, so calculate, if x is 1, it's indeterminate because it's 0 over 0. Determinate siya. Pero let us try to look at kung ano yung ina-approach ng function when x approaches 1. Kasi di naman siya pwede sa equal to 1 o di siya pwede sa 1. So let's use a number, or let 1 be equal to a number that is not equal to 1 but is close to 1. So let's say 0.999. That's close to 1. So our answer is 7.9955, which is close to 8. Okay? So how about ipa-close pa natin 0.9999999. The answer is much closer to 8. So tama yung answer natin, 8. So pwede natin i-try more than 1 pero close pa rin sa 1. So that's 1.00001. Our answer is 8.0000449 and so on. Okay? Which is very, very close to 8. So our answer is correct. Pero at x equal to 1, it's indeterminate or 0 over 0. Now let us proceed to problem 3.5, which is this. The limit of the quantity s plus 1 squared minus this quantity s minus 1 squared over s as s approaches to 0. So if s approaches to 0, you will notice na mas 0 to dito, no? Ito magiging negative 1 or positive 1 na to dito, then ito magiging 1 din. So it's indeterminate pa rin, 'di ba? At s equal to 0. So how do we solve this? So pareho pa rin. If you notice again, this is in the form a squared minus b squared. Diba? So wherein our a is s plus 1 and b is s minus 1. So therefore, this could be factored out. If this is a squared minus b squared, this could be factored out as a plus b times a minus b. Okay, so let's do that. So that becomes a limit as s approaches to 0 of yung a natin is s, ito na lang, s plus 1 plus b, which is s minus 1, then multiplied by a, which is s plus 1 minus s minus 1. Okay, then divided by s. So next, that would be the limit as x approaches to 0 of, so ito, madali lang naman, what will happen here is s plus 1 plus s minus 1, so cancel out yung 1, so this becomes 2s. So that's 2s multiplied by Dito naman, that would be s plus 1 minus s plus 1. So, makancel out yung s. So, that's 2. All over, sorry. We have over s. And we could cancel out s. Okay? Which is equal to the limit of 4 as s approaches 0. So, of course, the limit of a constant as the variable approaches to any value, that's still the constant, 4. So, our answer is 4. Okay, next, very easy problem. Problem 3.6, tama ba? 3.6. We have the limit of the absolute value of x minus a over x squared minus a squared as x approaches a from the left. So this is left side limit. Okay, left side limit siya. So meaning we are approaching x from the left, or the values of x are values close to a but less than a. Okay, so yun yung problem natin. So this is very easy kasi again, this is in the form a squared minus b squared, or this is a special product of a sum and difference. So therefore, we could rewrite our equation, this limit as the limit as x approaches a from the left of the absolute value of x minus a over, eto siya, we could factor this out as x minus a times x plus a. Okay, so if you notice, we have absolute value of x minus a over x minus a, and if you recall, we have absolute value of x over x that is actually equal to signum x. So therefore, this is actually signum x minus a. So we have the limit as x approaches a from the left of signum x minus a, diba? Divided by, so ilagay natin dito, divided by, meron pang x minus a sa ilalim. X plus a sa ilalim. Okay? Now, properties or theorems on limits we could rewrite this as the limit of the signum of x minus a as x approaches to a from the left over the limit of x plus a as x approaches a from the left. Okay, so medyo ayusin natin. So if you recall, what is the limit of signum x minus a as x approaches a from the left? Okay, so a from the left, that is a number less than a. So if you have a number here less than a, the result is a negative number. For example, a is 1. So if you have a number here that is less than 1 but close to 1, let's say 0.9, the result of 0.9 minus 1 is a negative number. So therefore, this is signum of a negative number which is equal to negative 1. Eto, balikan natin yung limits ng signum. Eto, here. If we have signum x from the left, or that's a negative number, that's equal to negative 1. The limit of the signum of x from the right, or a positive number, that's positive 1. So ulitin natin dito, in this particular problem, if a is a smaller number, or if we approach a number from the left, meaning we substitute a number that is close to a but less than a, the result here is negative. So the signum of a negative number, that's equal to negative 1. So we have negative 1 over, eto na, that would be a. Evaluate na natin a plus a, that's 2a. So the answer is negative 1 over 2a. So that's our answer. Okay, let's try another problem number 3.7. So we have the limit of tangent theta over sine 2 theta as theta approaches 0. So if you recall, tangent 0 is 0 and sine 0 is also 0. So this is 0 over 0 kung directly substitute natin to siya. So in other words, the domain is is a real number. No, yeah, a domain is the domain is are angles except for this 0. Also 180. Di din pwede siya sa 180 and 360. That will give us an indeterminate answer. So how do you solve this? So gagamit tayo ng identities for this. First, we know that tangent is sine over cosine. So this becomes sine theta over cosine theta. And sa ilalim naman, this is a double angle. So using the double angle identity, the identity for sine 2 theta, kung na-recall niyo sa trigonometry, that would be 2 sine theta cosine theta. So from here, we could cancel out sine theta, right? We cancel out sine theta. So our function now becomes the limit of 1/2, as theta approaches 0. So we have 1/2 times 1 over cosine squared theta. Okay, and we know that cosine 0 is 1. So therefore, this becomes 1 over 1 squared. So this becomes 1. So that would be the limit of 1/2 times 1, or the limit of 1/2 as theta approaches to 0. So the answer is just 1/2 because it's a constant number. The answer is 1/2. Okay, more problems. Problem 3.8. We have the limit of sine alpha times sine 2 alpha over 1 minus cosine alpha as alpha approaches 0. Okay, if alpha is 0, that means this becomes 0, and 1 minus cosine 0 is 1. So 0 over 0 ulit, so it's indeterminate. Okay, so evaluate na lang natin. Of course, the first clue here is the double angle. Para consistent siya, let us change this to its equivalent identity. So if you recall again, double angle for sine, we have sine alpha, then double angle for sine is 2 sine alpha cosine alpha, then divided by 1 minus cosine alpha. So we have the limit as alpha approaches 0. So this becomes 2 times sine alpha times sine alpha sine alpha. So we have 2 sine squared alpha cosine alpha divided by 1 minus cosine alpha. Okay, what's next? Okay, now notice that we have sine squared alpha here, and kung naalala nyo sa Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. Hence, sine squared theta is equal to 1 minus cosine squared theta. So therefore, sine squared alpha could be written as 1 minus cosine squared alpha. So this becomes 2 times 1 minus cosine squared alpha cosine alpha divided by 1 minus cosine alpha. But wait, there's more. Eto siya, this is again in the form a squared b squared because 1 is the square of 1. Diba? So therefore, eto siya could be factored out as 1 minus cosine alpha times 1 plus cosine alpha. So let's do exactly that. So we have the limit as alpha approaches to 0 of 2 times in factor form 1 plus cosine alpha times 1 minus cosine alpha times cosine alpha divided by 1 minus cosine alpha. So if we group this could be cancelled out. So we only have this, the limit of 2 times 1 plus cosine alpha times cosine alpha as alpha approaches 0. So if alpha is equal to 0, cosine 0 is 1. So 1. So this becomes 2 times 1 plus 1 times 1. So the answer is 4. Our answer is 4. Okay, another problem. Problem 3.9. We have the limit of sine alpha squared over alpha squared as alpha approaches 0. So remember na yung naka-square dito is alpha. Okay? So therefore, madali lang naman to, no? Because let's say we have let's call alpha as beta or alpha squared as beta. So that means this is simply sine beta over beta, and beta is still approaching 0 because if a squared alpha squared approaches 0, so if alpha approaches 0, if you square 0, that's still 0. So therefore, beta also approaches 0. So this is simply sine beta over beta as beta approaches 0. And we have the squeeze theorem for this. The answer is simply 1. Because from the theorem we discussed previously, we have this. The limit of sine alpha, in this case the angle alpha, over the same angle alpha as alpha approaches 0, the result is 1. So it also follows that the sine of beta over beta as beta approaches 0 is also 1. So yun lang. The answer is 1. Now let's try problem 3.10. We have the limit of sine kx over x as x approaches 0. So what would be the answer if we evaluate this? In this case, the angle involved is kx and the denominator is not kx, it's only x. So remember na dun sa squeeze theorem, we have sine alpha over alpha. So dapat pareho siyang alpha dito. So dapat kung kx to, kx din dito sa ilalim. Para ito, pag mag-approach siya sa 0, the result is 1. So in this case, di naman. So what we will do for this particular problem is we'll introduce k to the denominator. Pero so that di mabago yung value, we need to multiply this by 1 in the form of k. What I mean is we need to multiply that by k over k. So k over k is simply 1. Diba? So if we multiply a number by 1, the result is still the same, the number itself. So we'll have k over k times sine kx over x. So this becomes the limit of k times sine kx over kx as x approaches 0. So as x approaches 0, this approaches now to 1. So therefore, we have, kung in expanded form pa, this will become limit of k as x approaches 0 times the limit of sine kx as x over kx as x approaches 0. This is now equal to 1, and the limit of k is a constant, as x approaches to 0 is still k. So our answer is just k. Okay, next problem 3.11. So we have the limit of x squared minus 2 over x minus x squared as x approaches to negative infinity. So in this time, this involves a limit that approaches to infinity. Okay? So yung complicated dito, although this is still an easy problem, yung complicated dito is how do we use to compute infinity. Okay? So I think I already mentioned this during our bridging classes, that a number divided by 0 is equal to or approaches to infinity. So therefore, a number divided by infinity approaches to 0. Diba? Or ganito, if you have a number and you divide it by infinity, so sa calculus, we will think of infinity as a very large number. In this case, that's a very large negative number. Okay? So if you have a number and you divide it by a very large number, let's say 100 million, I don't know, pinaka zero na. Okay? But we divide it by a a very large number. The result is a very small number that approaches to 0. Okay? So therefore, if you divide a number by infinity, the result is 0. So dapat, yung variable dito should be contained in the denominator. Nasa denominator siya. So one way of manipulating this is just dividing all terms by the variable with the highest degree. In this case, the degree of both the numerator and the denominator is x squared. So we divide all terms by x squared. Ganon yung approach natin. So we'll do that. So the limit as x approaches to negative infinity. That would be equal to x squared over x squared minus 2 over x squared divided by x over x squared minus x squared over x squared. Of course, x squared over x squared is 1. So minus 2 over x squared divided by 1 over x minus 1. Okay? Then, pwede na tayo mag-evaluate if we substitute x with negative infinity. Okay? So this becomes 1 minus 2 over negative infinity squared divided by 1 over negative infinity minus 1. So what will happen kaya sa value dito? Okay. So anong mangyayari? If you square negative infinity, that will become positive infinity, right? So this will become a number, this will become 0. So 1 minus 0 is 1. Over, yung mangyayari dito is, this will become a number that is close to 0, pero negative man siya, negative. Okay? So, negative 1 gihapon dito. So, the result is negative 1. Okay? So, 1 over, 0 na to siya, 0 na to siya. So, 1 over negative 1 is negative 1. Okay, so how do we verify this using calculator? So, lagay lang natin yung function sa calculator. So, that's x squared minus 2 divided by x minus x squared. So, x approaches to infinity. Again, we'll imagine infinity as a very large number. In this case, it's negative infinity. So, that's a very large negative number. So, let's do precisely that. Let x be a very large negative number. So, I would choose negative 99999999999. So, that's a very large negative number. The result is negative 1. That's it. Next, for problem 3.12, so we have this. This is a limit where x approaches to 1 from the right. Kasi 1 plus. So, 1 from the right. Which is okay naman, reasonable, because if this is a number which is from the right, so meaning that's a number greater than 1. So, kung greater than 1 dito, hindi siya mani-negative. It doesn't exist kung from the left dito, meaning that's just a number less than 1. So if you square that, that would be more lesser than 1 or much lesser than 1. So magiging negative to dito. Okay? So kaya from the right yung approach natin. So how do we solve this? Ito siya, very easy lang. But naging example pa to. This is very easy because what we can do is pwede natin manipulate konti. I would look at square root of x squared minus x na very similar dito na sa x minus x squared, because this could be written as x squared minus x raised to 1/2, right? And yung denominator naman, I could factor out negative, so that becomes negative x squared minus x. So therefore, pareho na sila ng base. This is raised to 1/2 and this one is raised to 1. So the same base, if we divide that, we just subtract the exponents. No? So we have the limit as x approaches to 1 of negative x squared minus x raised to 1/2 minus 1. That's negative 1/2. Okay? So we have that. So that would be equal to the limit of So, ano nang pwedeng gawin dito? As x approaches to 1, that would be, pwede natin isulat siya as 1 over square root of x squared minus x. Okay? Okay, from the right pala. From the right. Okay. So, how do we now evaluate this? Kasi if mag-substitute na tayo, this becomes square root of 0, or this is 0, 1 over 0, that's infinity. And actually, the answer is infinity or negative infinity. Diba? Kasi we cannot do anything dito. Okay? Wala tayong magagawa. So, this is now a function with infinite limits. So, kung i-graph natin to siya, so, the value is approaching infinity. Negative infinity. So, pupunta siya pababa. So, i-try natin i-graph. Let us try to graph this. Tingnan natin yung value. So, pwede din, we can use calculator, pero para mas klaro na ma-picture out, so let's try this. X squared minus x divided by x minus x squared. So, observe the graph x squared. Ayan o. Tingnan natin yung x equal to 1. Ayun. So, at as x approaches from the right, actually, no? From the right, it approaches to negative infinity. Ganon siya. Okay? Kasi from the right din naman, yung sabi. Approaches from the right. From the left kasi, approaches from the left, it does not exist. No? If you notice, kasi wala siyang graph sa left of x minus 1. O x equals 1. Okay? So, yun yung natin, yung illustration natin. So, let's try the next problem. So, this is now problem 3.13. And this problem approaches to negative infinity. I think medyo mahababang solution ito. So, how do we solve this? Okay. So, what we can do here is remember or recall na this is a function or a limit that involves infinity. In this case, negative infinity. So therefore, in order to evaluate this, the variable should be at the denominator of each term. But in this case, denominator nga siya, pero dapat nasa kada term, nasa denominator siya, because a number divided by infinity would be 0. Doon lang tayo makaka-evaluate. So what we can do here is, ito yung technique natin. We could factor out x for each term. So factoring na yung gagamitin natin dito. So this would be equal to the limit as x approaches to negative infinity of 1 all over. So yung nasa square root, let me factor out x squared. Okay? Kasi if we factor out x squared, the square root of x squared, diba? That, may value siya. So if I factor out x squared, yung may iwan is 1 plus 2 over x. Tama ba? Because if I distribute this back, the result is this. So x squared times 1, that is x squared. X squared times 2 over x, that would be 2x. So simply, I just factored out x squared. Okay? And then minus x. Okay? What should I do next? Let me erase yung excess. So let me copy this. Okay, let me copy that. Then eto, what would be the square root of x squared? So if you recall our discussion on functions, especially absolute values and signum, and one-valued functions, I have mentioned that the square root of x squared is equal to the absolute value of x. So therefore, this is absolute value of x times the square root of 1 plus 2 over x minus x. Okay? So from here, we could factor out absolute value of x. Pwede no? So simply, we just divide dito, if we factor out absolute value of x, we divide this by absolute value of x, so mawala na siya, and this, we divide this by the absolute value of x. Diba? So, pwedeng ganun. Okay, that is one approach. Okay, so let's do that. So, we'll have the limit, the limit of, as x approaches to negative infinity, of 1 over, we factor out the absolute value of x. Okay, so this becomes square root of 1 plus 2 over x, then minus x over absolute value of x. And again, if you notice, this is now signum, no? And if it's negative infinity, so this is negative infinity over absolute value of negative infinity, so this becomes negative 1, right? So this value is negative 1 because we have negative infinity here. Okay, so therefore we have evaluate now, meaning if we now use this function, so let me copy that and substitute x, all x to infinity, substitute by infinity. So this is negative infinity and this becomes negative infinity. And remember na since signum to siya, this is negative 1, right? That is negative 1. Okay? Actually, obvious na because 1 divided by infinity or negative infinity, this is 0, right? So this is 0 over whatever is this value here. But in this case, magiging 0 to siya, diba? So that would be square root of 1. So square root of 1 is 1 plus 1 is 2. So 2 times infinity is still infinity and 1 over infinity is 0. So our answer is 0. Okay? So we could verify that using calculator. So let's try to verify that. So sa calculator, if we type this particular function 1 over square root of x squared plus 2x and then minus x, okay, and you calculate, ayan, that is negative infinity. That's a very large number, na negative. So that's negative infinity. So the result is this. So kung titingnan mo, times 10 raised to negative 16, that means that's 0.00000000005. So yun yung answer niya dyan. So meaning that is very close to 0. So our answer is 0. So the limit is at 0. Okay? Now, what I want you to do as your assignment, okay? Proof na you watch this video. So I want you to do is to calculate the limit as this is the same problem, the limit of this same problem as x approaches to positive infinity this time. Okay, so solve niyo yung positive infinity. Of course, you can verify the answer using calculator, diba? So if mag-substitute tayo, ayan, a large number na positive, the result is 1. So the answer is 1 if this approaches to positive infinity. So what I want you to do is to give me the solution or the proof that the answer is indeed 1. Okay, so that would be the proof that you watch this video. Okay, so that would be your assignment. So as soon as na panood mo tong video na to, so solve directly, then private message me your answer or your proof, your solution.